Eureka!
The story so far. The tendency things have to keep on doing what they're already doing is called inertia. Mass is a measure of inertia. But in order to make a thing change what it's doing, you have to use force. And force varies not only with mass, but also with change of speed. And now, acceleration, part 1. If you wanted to exert as little force as possible, which of these two bikes would you choose to ride? No contest. The modern racing bike has much less mass than the old-fashioned bike, and therefore much less inertia. So you'll need less force to make it move. But wait, is that all that force is proportional to? To mass? Isn't there something else? Yes, change of speed. Mustn't forget that. Force is also proportional to change of speed. If you want to reduce the force you put into pedaling, you're better to go from 0 to 25 kilometers an hour than to try to zoom up to 50 kilometers an hour. Too easy, you think? Well, go on then. Ride the bike at 25 kilometers an hour. Stop. That wasn't 25 kilometers an hour. You weren't even doing 5 kilometers an hour. That's right. It takes time to reach the speed you want to go at. In the first second you start pedaling, you'll be lucky to get up to 3 kilometers an hour. After the second, you may reach 6. After the third second, 9, and so on. It'll probably take you 8 seconds or so to reach 25 kilometers an hour. Let's look at that again. That's it. Now you're going at your top speed. Is this when you're exerting maximum force? You think so? Well, take your feet off the pedals then. You're hardly losing any speed at all, are you? You're exerting 0 force, and yet if it weren't for the bumpiness of the road and the wind resistance slowing you down, you'd still be going at 25 kilometers an hour. Why? Because of the first rule of physics. Things like to keep on doing what they're already doing. It isn't the speed of 25 kilometers an hour itself that requires effort or force from you. It's getting up to that speed. That's why we say that force varies with mass and change of speed. But the more quickly you change your speed, the more force you'll have to exert. If making your bike go from 0 to 25 kilometers an hour in 8 seconds requires 1 unit of force, then making it go from 0 to 25 kilometers an hour in half that time, in 4 seconds, will require 2 units of force. The thing is, we're not just talking about change of speed, but about an increase of speed in a certain time. In other words, we're talking about rate of change of speed. So we should say that force varies with mass and rate of change of speed. But that's a very long sentence, so we shorten it by using the other word for rate of change of speed: acceleration. Force varies with mass and acceleration. And we can shorten that still further by turning it into an equation. Force equals mass times acceleration, which just so happens to be the second rule of physics. This should be obvious to cyclists, and even more obvious to motorists, who are always going on about acceleration. But what about a baseball pitcher? Does he need time to get the ball up to its top speed? All right. Pitch that ball at 50 kilometers an hour. Freeze. It isn't going at 50 kilometers an hour at this point. More like 10 kilometers an hour. This is just the beginning of your wind-up. A bit later, the ball may reach 20 kilometers an hour, then 30, then 40. But it's only at the last split second as it leaves your hand that it reaches its top speed. The fact is, you don't so much pitch a ball at 50 kilometers an hour as accelerate it up to 50 kilometers an hour. That's what your wind-up is for. You may call yourself a baseball pitcher if you wish, but in reality, you're a baseball accelerator.